So before we get started with calculus itself, I want to do a few videos that tell you about some pre-calculus concepts that you need to really know and pay attention to. And in this video, we'll discuss general problem-solving techniques. Okay, and this is what I like to call this video is step one is philosophy. Mathematics itself stems from philosophy, because philosophy is simply a rigorous application of thinking. It deals with definitions of terms. It deals with the logical relationships between terms. And so mathematics really starts with understanding and defining your terms. So a long time ago, they did they were doing surveys of students in elementary and high school, and they were analyzing their math skills, and they gave them a question just to see what people would do with it. What they did is they gave them a question. If you had, I forget exactly what the numbers were, but if a shepherd has 5 sheep and 4 goats, how old is the shepherd? Now you might be thinking, there's not enough information to answer that question. And you'd be right. But the problem is that a lot of people, when they get numbers, they just want to automatically take those numbers and put them into a formula and solve. They don't stop and think about, what do those numbers mean? And so what they would do is, given this question, some people would try adding the numbers. They'd add 4 and 5 and get 9. They say the shepherd's 9 years old. Or they might multiply 4 times 5 and get 20 and say the shepherd must be 20 years old. They don't stop and think about what the formula means before applying some formula that they know to the question. The idea that someone would give them a question that the answer we don't know didn't occur to them. So they just try to do something. Okay, so the first thing that we need to learn in math is we need to learn philosophy. We need to understand what we're doing and why. And in philosophy, in the philosophy of math, there's several things that we need to do. So I have a 3-step process for problem solving that I like to apply to all sorts of things. And the 3 steps are very general, but I think you'll find that they give you a good framework for understanding problem solving. So the first step, as I mentioned, is philosophy. And so under philosophy, what you need to do is you need to identify what you know, you need to identify what you don't know. So under what you know, that's all the values that they give you in the question. Okay? So everything they give you, just list it out. Take it out of the paragraph or whatever and list out what you're given. Okay? So also, you can talk about relationships that you know. You know, is there a geometric figure that's there? Well, what do we know about that geometric figure? But what's even more important is to list out what you don't know. The major advance of algebra over what was previously happening in math is that we explicitly named our ignorance. Okay, when you come up with letters like X or Y or Z, these stand for specific pieces of ignorance. And by being able to substitute in our ignorance with something concrete, we can then manipulate what we know to understand what we don't know. And so this is the amazing revelation of algebra, is that simply by naming the things that we're ignorant about, we can then come to knowledge about them. Okay? So we list out what we know, we list out what we don't know, and then we list out the relationships. And we also label whether or not there's a known relationship, or if there's a relationship that we would like to see, we just list them all out, and this gives us kind of our foundational philosophy. What do these things mean? What do we know, and what do we don't? Okay? So the second step, in the second step, we do the meat of the problem solving. Okay? We convert our questions into answers. And this is actually what I love about mathematics. In every other subject, if I don't know something, I have to go out and figure it out. I have to go, if I don't know something about biology, I have to go find an organism and test it out. If I don't know something about physics, I have to go and, drop balls off buildings or something like that and measure things and figure it out. But that's not true in math. In mathematics, our questions become our answers. And we do this using logic. Okay, so we use, there's a whole lot of, all of mathematics is basically applied logic. And so all the manipulations of formulas that you do, all of those things are simply the conversion of our questions into our answers using logic. And there's two main pieces of logic that you will use over and over and over again. And they both deal with equality. Okay? And so if we have two things that are equal, we have A and B. If we have two things that are equal, then the rules of logic tell us two things that's very important. The first one is that if A is equal to B, they're exactly equal, then anytime that we have A, we can substitute B in for it. And anytime we have B, we can substitute A for it. And this is true for any two things that are equal. Okay? So if we have something like, V plus 3 equals X plus 1, well, anytime in any other equation where we have V plus 3, we can simply substitute in X plus 1 because they're identical. They're the same thing. Anytime we have X plus 1, we can substitute in V plus 3 because they're the same thing. Okay, so the second rule of equality is that these two quantities will remain equal no matter what we do to them, as long as we do the same thing to both sides. Okay, so if these two quantities are equal, they'll still be equal if we add 1 to both of them. If we multiply both of them by 5, they will remain equal. As long as we do the same thing to both of them, they'll still be equal. And the way that I like to think about this is, you don't even need numbers to understand this. Imagine that we have two paintings. And, I'm not the greatest artist in the world. So we're going to pretend like these are equivalent. So these two paintings are equal. And they will remain the same, they will remain equal paintings as long as I do the same thing to both of them. So if I draw a line in the corner and a line in the corner, they're still equal. If I color in the face and I color in the face, they're still equal. So as long as I do the same thing to both sides, no matter what it is that I do, they'll remain equal. And so you can apply these rules and all your other mathematics rules as well until you get it to a form that tells you the answer. And step 3 is a little hard to describe, but we'll have an example shortly. And that is, we will convert our steps into a formula. And basically what this allows us to do is to automate step 2 so that we actually don't ever have to do it again. Once we have understood how this process works, we can then create a formula that will do this process for us, but without any of the hard thinking, right? So the hard thinking only occurs once, and then we can replicate it over and over and over again. And it's very sad. This is one of the most important parts of math, but it gets left out of almost every mathematics textbook because it would prevent the textbook from being able to give you repetitive problems over and over again, because once you learn the formula, then you don't need to solve the problem in the way that it suggests. So a lot of mathematics books skip part 3, but it's actually the most important because that's where all of your formulas come from. They come from someone who solved a problem, and then they're like, well, let's convert those steps into a formula. And so this allows you to create your own formulas for whatever it is you're trying to do. So you only have to solve the math question once. So those are our 3 steps. Now let's apply them to a specific problem. So the problem that we'll be looking at is to find 3 consecutive odd integers that add up to 111. Okay, so this is our problem. And so step 1, if you remember, is philosophy. Okay, so what do we know? Well, we know the 111. This word is important. We're adding. Okay, so we're adding. So we've got 3 consecutive odd integers, but we don't know what they are. So remember what we do when we have something that we don't know? We name our ignorance. Okay, so we have 3 things that we don't know. So we need 3 different names. So we will say, we'll call them X, Y, and Z. Okay, so these are the things that we're ignorant about. We don't know what these 3 consecutive odd integers are, but there's something that we do know, and that is they add. So that means we're going to put plus signs between them. They add up to 111. Okay, so that's the first thing that we know. Okay, so that we've named our ignorance and we've named some of our knowledge, but we actually know more based on the problem. It says they are consecutive odd integers. So what do we know about odd integers? Well, first of all, they're not divisible by 2. Well, that's good. But also, if we think about, let's just name some odd integers, right? 1 is odd, 3 is odd, 5 is odd, 7 is odd. What do we know about these? Well, notice that between each one, we're adding 2. So to get from one odd integer to the next one, we add 2. So if these are consecutive odd integers, then that means that if X is the first one, X is our first odd integer, then Y is going to be X plus 2, and Z is going to be Y plus 2. Okay, so now we have 3 formulas and we have 3 unknowns. And one thing that you should know is that you should have at least as many equations as the number of unknowns. So since we have 3 equations and 3 unknowns, we actually have the possibility of a solution. So what do we do? Well, we'll use our rules of equality. So y equals x plus 2. Let's move that up here. So y equals x plus 2. And z equals y plus 2. So we can use our rules of equality. What's the rule of equality? Well, it says that if two things are equal, we can substitute for them. So if we substitute x plus 2 into this equation, we'll wind up with one less variable, one less thing that we don't know in our problem. So we'll say, actually, let's start with z. Okay, z equals y plus 2. So we'll say x plus y plus y plus 2. And when I substituted this in, I used parentheses, which is a good habit, which means that if I substitute this in with a parentheses, it means that this is a single unit. Okay, so now I have x's and y's, but I also have an equation for y. I have this equality that says any place I have y, I can substitute it with x plus 2. So it's going to say x plus 2 plus x plus 2 plus 2 equals 111. Okay, so now we're making progress. So now we actually only have one variable left. Okay, so now if you remember your rules of association, addition allows you to both change your parentheses wherever you want them, as long as they're all addition, and we're all addition, and then allows you to regroup things however you want, and rearrange things. So we can transpose this into x plus x plus x plus 2 plus 2 plus 2 equals 111, which we can then simplify. Notice we've got 3 x's, so we can say 3x plus, and 2 plus 2 plus 2 is 6, equals 111. Okay, so now we're getting close. So remember, the other rule of equality is you can do anything you want as long as you do it to both sides. So what we really want to do, we'll know what x is when it's all by itself in one side. So what we really want to do is do things that will cause x to be more alone than it currently is. So we have 3x plus 6. So let's subtract 6 from both sides. Okay, what does this become? Well, our 6 minus 6 is 0, so that cancels out. And 111 minus 6 becomes 105. Now what do we do? Well, to get x all by itself, all we need to do is 3 times x. So if we divide by 3, we'll cancel out our 3. So we have to do it to both sides so they stay equal. Divided by 3, divided by 3. It's an ugly 3. So this cancels out to give us just x. And 105 divided by 3 is 35. So our final result is that x is 35. So that means y is x plus 2. So it must be 37. And z is y plus 2. So it must be 39. So now we have our 3 unknowns. They're now known. That's amazing. You know, it's not, this may seem simplistic, but this type of thinking, if you go through it, will help you to understand what's happening. Okay, so now that's step 2. It's our converting our, we converted our question into our answer using logic. We used the rules of equality, and we also used the rules of addition. Okay, so now what's the next step? The next step is to convert our series of steps into a formula so that we never have to do the thought process again. So how do we do that? So let's say that instead of them adding up to 111, let's generalize this so that it's any kind of, it adds up to any given number. So, and what we'll do is instead of giving it a number, we'll call this n. Okay? We'll treat it like a number. We'll pretend that it's a number, but it's actually going to be a letter. Okay? So, let's erase some of this. Okay, so now x plus y plus z is no longer the specific number 111, but they will add up to n. Okay, so we're going to do the same process as before, but we're going to use n as a stand-in for 111. So we're going to do our substitutions. I'm going to say x, and I'm going to write it a little bit smaller this time, x plus 2, kind of skipping on some of the steps as well. X plus 2 equals n. And then we'll rearrange this to x plus x plus x plus 2 plus 2 plus 2 equals n. That'll give us 3x plus 6 equals n. And then we're going to do the same process. We're going to solve for x, but n will no longer be a physical number. We'll just have to pretend that it is. So we'll subtract 6 from both sides. We'll say 3x equals n minus 6. So we're going to treat that as a number even though that it's not. Now we're going to divide both sides by 3. That's going to give us x equals n minus 6 divided by 3. And so here is our final formula. So no matter what our question is, this formula will give us our answer. We don't have to go through the logical process again. We have invented a formula that will tell us the answer. Okay? So what are 3 consecutive integers that add up to 9? Okay, well, we'll put in 9 for n. So 9 minus 6 is 3, and 3 divided by 3 is 1. So our 3 consecutive integers are 1, 3, 5. And we can see that 1 plus 3 plus 5 does indeed equal 9. And so any odd number that has 3 consecutive odd integers that add up to it can be solved using this formula. Okay, so we have converted our steps into a formula, so we never have to go through the steps again. We can simply apply the formula to get the answer. And that's super powerful because, all through life, you can solve the problem, but you only have to solve it once. After you've solved it, you never have to solve it again. Just use the formula that you came up with. So that's my general problem-solving framework. The 3 steps. Step 1 is philosophy, identifying knowns and naming your ignorance. Name your unknowns. Step 2 is we convert our questions into answers using logic. And step 3 is that we automate step 2 by converting our steps into a formula that you can use over and over and over again. Okay? So that is the general problem-solving formula, and we'll do things like this all throughout the course. Anyway, until next time, I hope you enjoy your math.